Hello and welcome to the first video in What Are Programs Doing? My name is Ben Bryant. 2 years ago I quit my job in the security industry to start building new stuff, and the first thing I did was to figure out the format of PML files, because they capture a treasure trove of information about what programs are doing on your machine. Viewer9 is a free utility we are building, and it lets you query PMLs. If you are familiar with Procmon and have your own PMLs, you can try it. If you don't know Procmon, short for Process Monitor, it's a Microsoft utility that lets you record the activity of programs and save it to a PML file. Here I have a variety of PMLs and 5 more in a subdir. You can locate your PMLs by typing the path in the command box. Today we want to take a quick look into how the Chrome browser works. So to look for Chrome, enter the Q command for query. exe name contains Chrome. The value Chrome is not case sensitive. The colon means contains. You use it all the time. It's way more useful than equals. So 5 PMLs contained Chrome. That was out of 15 PMLs in this directory and the subdirectory. 1 was from 32-bit Windows in green and 4 from 64-bit in blue. The last 2 are captures of Chrome installs, so there were additional Chrome-related exes there. The parentheses after the exe name is the number of processes running that exe. By default, this query showed the company and description, but I could change my query to tell it to show version and path. Let's click into the Chrome with 82 processes. The exe view starts with the exe fields, and then it provides a comparison of the processes. These are the process fields that were the same for all 82 processes. Then it goes through each process showing the remaining fields. The first one is proc 46. 46 is the index into this PML's internal array of processes, not to be confused with the PID, which is 3444. The parent proc is Explorer. This is the parent you see when you launch Chrome from the desktop. Looking below, we can see that 46 was the parent proc of the other Chrome processes. So in other words, 46 was the primary process that spawned the others. And we can see in the command line the roles of the different processes. Crashpad handler, GPU, utility for network, utility for storage, and a whole bunch of renderers. So even though Chrome appears as one program, there are all these processes performing distinct roles. These charts break down the activities of each process. We see the only ones doing network activities are the primary and the networking process. Looking through, a lot of them are accessing the registry, but only for read. Are any writing to the registry? Only the primary one writes to the registry, a tiny bit. I wanted to go back out and look at another way of drilling into the data via modules. For example, we can look for network-related modules by finding descriptions with the word network. There were 9 in the first PML and 45 in the second. It only shows the first 10. You could click in to see all 45. But going back, often you'll find that there are a lot of modules loaded that are never involved in any events. So to see events that contain these modules in their call stack, we can use the events specifier to tell the query we want matching events instead of matching modules. Okay, got a lot of hits across a lot of applications and operations. Let's go into a Chrome TCP Connect event. This is the first time we're looking at an event view, and what stands out is that it shows a binary area of the PML, indicating where each field is parsed from. This comes from the bootstrapping stage of viewer9, figuring out the PML format. Scrolling down, we can see the call stack for this event, and because our query selected certain modules, it highlights the ones that matched in this event. Above on the right is the process that performed this TCP connect, proc41. Going into it shows a larger version of the chart that breaks down the activity, giving event counts and read, write, send, receive data sizes. Also, there's a list of all the modules loaded, and highlighted are the ones that match the query we came here from. The command line shows the type of Chrome process is networking, as expected. This whole multi-process browser engine framework is actually used by apps other than Chrome, originating from the Chromium project. We could take this distinctive -- type equals argument and search for other programs with it in the command line. So go back out, use quotes around the value because of the special characters. See that Slack has a very similar command line? Opera browser too. Teams, Skype, Avast, even Spotify. This listing is kind of busy. We can add the exes specifier to get a cleaner list. Edge is another browser built on this framework. Thank you for watching.